Hello, humans on lockdown. Time to carry another AP Maths, and we are continuing with the differentiation of E and ln. Remember on your formula sheet, ln AB is ln A plus ln B, ln A of B, ln A minus ln B, ln x to the n ln x, derivative of e to the x, derivative of ln x 1 of x, okay, if x is greater than 0, and ln of e is 1. Right, we're going to be working, make sure you've got them in front of you. I sent them to you, the supplementary notes from Mindborn Maths on differentiation of E and ln. And we're going to start off by doing F number 1, 2, and 3. And your first question is, go find the derivative of e to the 2x times sine 2x. Okay, so you've got a function times another function, so you're going to have to use the product rule because you're differentiating. Give it a go. Welcome back. Right, so if I use the product rule says differentiate the first one. So it's going to be the derivative of e to the 2x times by sine 2x plus, and it's the other way around. Okay, so it's going to be e2x times by the derivative of sine 2x. You can skip out that step if you want to and go straight to this step. The derivative of e to the 2x is going to be, well, you're going to have to use the chain rule. So it's going to be e to the 2x, that's the derivative of the outside. The inside function is 2x, and the derivative of 2x is 2. So that's the chain rule. I've still got to times it by sine 2x plus, and here I'm going to have e to the 2x. The derivative of sine 2x is cos 2x. Okay, and then that's the derivative of the outside function. I'm using the chain rule again here. Okay, so it's cos 2x, and then the derivative of 2x is 2. Okay, the derivative of outside times by the derivative of inside. I use the chain rule to get to there as well. And if we make that prettier, I get 2e2x sine 2x plus 2e2x cos 2x. Okay. Good times. Get that done. Okay. Try these, please. Derivative of 2e to the 2x over cos x. Sinead, you're going to do it for the class. So get going, all of you. You remember you're going to have to use the quotient rule. Okay. Right. So using the quotient rule, we're going to take the derivative of the top, which is the derivative of 2e2x, okay, times by the bottom, the numerator, which is the denominator, which is cos x, minus, and it's the other way around, the numerator times the derivative of cos x all over the denominator squared, which is cos squared x. Okay, and then here, well, we'll keep if I differentiate that, I keep the 2 over there. The derivative of e2x is going to be, using the chain rule, e2x. Okay, so I'm differentiating e2x. It's e to the 2x times the derivative of 2x, which is 2, times by cos x. And then over here, we're going to have minus 2e2x times by the derivative of cos x is negative sine x all over cos squared x. And that's, to make it prettier, is going to become 4e2x cos x plus 2e2x sine x over cos squared x. And Janae, have a look at your answer, see that it coincides with that. If it's correct, give yourself a pat on the back. Right, next we're going to do F3. Okie dokie, Tracy. Cara, you give this one a go. The derivative of ln x over x cubed. Okay, doen jou beste. En ons gebruik die quotient rule. Dis op jou informasie bladsy. So gebruik dit en onthou dat die derivative van ln x is 1 oor x. Okay, right, give it a go everyone. Right, so if I'm using the derivative of ln x over x cubed, I'm going to take the derivative of the top, you can skip out the step as I said, the derivative of the top function. So I'm looking for the derivative of ln x times by the denominator minus ln x times by the derivative of x cubed all over x cubed. Okay, make that pretty, simplify it. And the derivative of ln x is 1 oor x multiplicaat x3 minus ln x en 3x squared. Die hele ding oor x3 en ons kan dit prettier maak. As you multiply hierdie twee together, you end up with x squared, okay, minus ln x times 3x squared over x cubed, and we can even make it mooier, baie mooier, as ons noem 8x squared, en dan is ons gelaat met 1 minus 3 ln x oor x3, en dit bekom 1 minus 3 ln x oor x. Okay, so to check it, 1x x cubed, x squared, there's an x cubed 3x squared, so it becomes my x squared minus, it looks right to me. If I made any deliberate errors, please let me know by post. Reg, Carla, I hope you got that right. If you did, high five yourself. Oh, I just quickly checked. There was a deliberate error. That should have been squared. So that would become x to the 6. Haha, got you all. Over x to the 6. So if you take out x squared and you've got x to the 6, you're going to get left with 1 minus 3 ln x over x to the 4. Sorry about that. Good day. Next one from your supplementary notes, Mindful Maths, is G. Right, so the question is, you're given the function y is equal to ln square root of 2x minus 1. First question is go find the domain. Then, secondly, I want you to go differentiate that by using the chain rule. Okay, and then I want you to do the same question by first using your log laws. So first of all, the domain, and let's have Boati doing the domain. And Boati says, well, it's pretty easy because that simply has to be bigger than 0. So x must be bigger than a half, right? Because if that's bigger than 0, the square root of that will be bigger than 0, and then ln will be applied to positive values. So your domain is x is greater than half. Right, now I want to go try to do this using the chain rule. Frankie, you're going to do that, please, and then you're going to come show the class. Right, give it a go, everyone, while Frankie's doing it on the board. And you'll be pleased to know that Frankie got it correct, and this is how she did it. She said, well, I'm going to use a chain rule. Let's start off and write the third as the power of a half. Okay. We're not going to use a log law here, we're just going to start off with the chain rule. So the derivative of ln of a function is 1 over that function. So I'm going to use the chain rule now. So it's going to be 1 over 2x minus 1 to the half. That's just using that. So I'm using the chain rule to get from here to here. Chain rule. And I'm saying 1 over that times by the derivative of 2x minus 1 to the half. The derivative of the outside times by the derivative of the inside. So I'm going to have 1 over 2x minus 1 to the half. Okay. And then this is going to be a half 2x minus 1 to the negative half. That's the derivative of the outside function. Times by the derivative of the inside function is the derivative of 2x minus 1. And the derivative of 2x minus 1 is 2. Okay. If we make that prettier, well, the half times the 2 will cancel out. And I can move that power to the bottom because at the moment it's over 1. Move the power down, the sign of the exponent changes. So I'm left with 1 over 2x minus 1 to the half. That one over there. And when I move that one down, I'm going to have times by 2x minus 1 to the half, which is awesome, because now you've got powers with the same base, so you can add the exponents. And a half plus a half is 1. So you get left with 2x minus 1 to the 1, which is just 1 over 2x minus 1, based on the fact that x is bigger than half. So I think all of you should WhatsApp Frankie after this and congratulate her on using the chain rule so successfully. Right, and now we'll have the girl from Eden Glen, whose name shall not be mentioned, trying to do this one, but by starting off with the log law and then differentiating. So start with the log laws and then differentiate and go see what happens. Give that a go. You should get the same answer. You should get 1 over 2x minus 1. Right, so try it. So now we're going to use the log laws first. So we're going to say 2x minus 1 to the half. And then using this log law, ln x to the n is n ln x. We're going to say this becomes the derivative of a half. I haven't differentiated yet, I'm just using the log law. Ln 2x minus 1, okay, which is equal to, well, the constant just stays there. Okay, and then the derivative of ln 2x minus 1 is going to be 1 over that. So it's going to be 1 over 2x minus 1. Okay, that's the outside. I'm using the chain rule again. Times the derivative of the inside function. The derivative of 2x minus 1 is 2. If you want, you can make it 2 over 1. Once again, the 2's cancel out. And you're left with 1 over 2x minus 1. And you'll all be relieved to know that the girl from Eden Glen got this correct as well. Well done to the East. Never underestimate the people from the East. They may have big heads, but that actually helps. Right. Alright, before we continue, I just realized I forgot to wish, I know you say Happy Ramadan, but I forgot to wish the Muslim students in my class Happy Ramadan. Happy Ramadan, all of you. I hope it is going well and you are surviving your fast during daylight hours. So, the first question, we're doing H from your supplementary notes. You've got y is equal to ln over applied to x squared over x minus 2. First question is go find the domain of that, and if you could be so kind, Bianca, to do that for us, that we must appreciate it. Another person from the East. So the domain, well, that whole thing has to be positive, and x squared is always positive. Okay, so the only criteria then is that x minus 2 must be bigger than 0, so your domain is x is bigger than 2, right? Here's your domain. Okay, and then what I want you to do is differentiate this, find the derivative of ln x squared over x minus 2. First of all, I want you to try the chain rule, and if we can have the original rat bag doing the sum, she knows who she is, okay, the one who needs regular forgiveness. So the derivative of ln x squared over x minus 2, using the chain rule, give it a go. Everyone try it first. Use the chain rule first. I mean, not the chain rule, Sogaman. The quotient rule. It's driving me mad. So try the quotient rule first. Okay, before you use any log rules. Right. So if I use the quotient rule, or first it's a chain and quotient rule, I guess. Okay. The chain rule says this will be the derivative of the outside, ln of anything will be 1 over x squared x minus 2. Okay, that's the derivative of the outside function. Okay, ln of something is 1 over that, times by the derivative of the inside function, which is the derivative of x squared over x minus 2. And to do that derivative, you're going to have to use the quotient rule. Right, finish it off if you haven't yet done so. And if I neaten it up, Ratbag told me that you're going to get x minus 2 over x squared, which is indeed correct. Then to do this derivative, it's going to be the derivative of the top function. Derivative of x squared is going to be 2x times the denominator, which is x minus 2, minus the top function, which is x squared, times the derivative of the denominator, and the derivative of x minus 2 is just equal to 1, all over the denominator squared. Okay, and if you make that prettier, you're going to get, well, the 1x minus 2 will cancel with the other x minus 2, so you're going to left with just 1x minus 2. Still got the x squared. Okay, and here we're going to have 2x squared minus x squared, which is x squared. 2x squared minus x squared is x squared. And then we're going to have, this doesn't feel right, x, let's just check, 2x times x minus 2 minus x squared times 1. Okay, so I get 2x squared minus x squared is x squared, minus 4x, x squared minus 4x, 2x squared, sorry, minus 4x. So it's, yeah, it's just x squared minus 4x. Okay, no, that's fine. Okay, and I can take out an x, and I'm left with x minus 4 over x squared, x minus 2, which gives us x minus 4 over x minus 2. I don't know why, I've got the feeling I might have made a little bit error there. Ratbag, just check if I'm right. Okay, I just phoned Ratbag and she said I was right. So that is indeed correct. X minus 4 over x minus 2. Now that was a bit of a pain in the bum. But now I want to do that same question using your log laws. Okay, so go use your log laws to do that. And if I do that using my log laws, okay, well, you're going to use this log law, that ln a over b is equal to ln a minus b. Okay, so before we differentiate, I'm going to apply a log law. So it's going to become ln x squared minus ln x minus 2. Okay, I can even make it prettier, easier if you want, and make it the derivative of 2 ln x, just using a log law, minus ln x minus 2. And now go differentiate each of those separately, and if you differentiate them separately, you get 2 times the derivative of ln x is 1 over x, minus 1 over x minus 2, times the derivative of x minus 2 is just 1. Okay, you have to put that in if you don't want it. So I get 2 over x minus 1 over x minus 2, and if I get a common denominator, x minus 2, you're going to have 2 times x minus 2, which is 2x. 2 times x minus 2 is 2x minus 4, minus x, which gives you x minus 4 over x minus 2, which is tremendous news because that is the same as the other way. So in general, if you look at this example and the example that we did before, it's generally quite a lot easier, not always, but if you've got ln of a quotient or ln of a product, to apply the log law first and get them to separate terms before you differentiate, than to just go straight into your differentiating using a combination of the chain rule and the product or quotient rule. So generally, if it's ln applied to a quotient or a product, use the log law first, and then go and differentiate. Lovely. Okay, humans. Last one I'm going to do with you. You've got f of x is equal to ln e to the x minus 1, and f dash of x is equal to 2. Okay, this is question M from your supplementary notes. Required to prove that x is equal to ln 2. And I think we're going to get Radine's best Liverpool supporter to do this. Henna, so off you go, give it a try. And yep, you'll be pleased to know Henna indeed got it correct, obviously, because she supports Liverpool. And if Liverpool don't get the Premier League, you may have to launch some kind of terrorist attack. So, f dash x, okay, well if I differentiate then e to the x minus 1, it's going to be 1 over e to the x minus 1. I'm just using the chain rule here. So that's the outside function, and the derivative of e to the x times by the derivative, I'll write that down, but you don't have to, e to the x minus 1. And the derivative of e to the x minus 1 is just, well, the derivative of e to the x is e to the x, and the derivative of minus 1 is 0. So the derivative of e to the x minus 1 is simply going to be e to the x. And so I've got that, times that out. That's in the numerator, and the denominator, it's e to the x minus 1. So I've got e to the x minus 1. That is f dash x. Okay, but we know that they told us that f dash x is equal to 2. Okay, so both of these are f dash x. So therefore, e to the x over e to the x minus 1 is equal to 2. Okay, and if I multiply that out, I get e to the x is equal to 2 times e to the x minus 1. So e to the x is equal to 2e to the x minus 2. And let's move the negative 2 across there. So I get 2e to the x minus e to the x is e to the x. So 2 is equal to e to the x, but I've got to show that x is equal to ln 2. Well, if you use a definition now, okay, you're going to have log base e of 2 is equal to x. In other words, ln 2 is equal to x. Henna, you are a scholar as well as a wise football supporter. Well done. And the last thing left for you bipedal vermin to do is mind math, sub notes, and I just want you to do on your own I number 1 and J, K, L and N. I will send the memo to you, and that is all the new work that is required up till Tuesday's. It's going to be examined up till Tuesday's test. Hope you have a tremendous time. Farewell. Hope you're not missing me too much. Arrivederci.